All right, we back on this 5.3 that we're turning into a 427. Hang loose and we'll get into it. So Andrew got it in the home today, and if you remember the first episode, we talked about we were going to hone the cylinders, the actual raw aluminum to get it round and straight and on size before we put the liners in. So I went ahead and honed the other side. But what happens is, especially when you bore these sleeves out manual, is we center on one hole and then we bore that hole completely to size. And then we move over and we'll bore the next hole and on and on and on. Whereas, when you do it in like a machining center, or if you got multiple boring heads or positioning, whatever system you got, you can bore all 8 holes a little bit at a time, 30, 40 thousandths, whatever. And so that lets the block relax gradually, instead of getting this hole done and round and then blowing all that material out of this hole, and now this hole's round, but this hole ain't round anymore. And then so that works. So when you get to the last hole, this hole's round, but none of these 3 are round anymore. And I could tell when I honed it, which, this ain't my first rodeo, but that's one of the reasons why we hone them afterwards. And the second reason is, and we talked about it a little bit in the first video, is surface finish. So we want the sleeve to have a really, really smooth surface finish so it can transfer heat from the cylinder into the water jacket. And I used to see it like, I'd see cylinder heads where people had put guides in or bronze liners, and they would have a really coarse finish, and it would just burn up the guides. No time, Billy Bob have his head done, and in 2 months, 3 months, the guides are just absolutely gone, because the surface finish was so rough on the parent bore that the guide couldn't transfer the heat into the cylinder head, so it just held it, and then it just burned it to the ground. So that's why it's really important to have a nice surface finish. So what I've done, let me flip the ball. Well, come over here and let me. So these things are just paper thin here. So I always just take some needle nose pliers and break that little section out, and then we file it nice and uniform. So there'll be just a little small gap right there. And so the other side, yep. So the other side, we've got it honed. We knocked these out, and you can see, it's pretty uniform. And I know some people were asking about bore centers and, how accurate was it doing it manually versus doing it in a CNC. I guess to talk about that a second. So here's the scenario. So I don't care how you bored the holes, right? There's a way to make it right in a CNC, but I see a whole bunch of people that don't do it. So the way it should be done, if you're going to do it in a CNC, is obviously this thing, kind of like when we deck a block, the mains are sitting on a 2-inch precision bar. And that should be Y0. And then some dimension, wherever you're going to go off of, the face of the block, the dial pin, whatever it is. And that should be X0. And then each hole location should be programmed from a given spot, a given location that we can verify, and then we can fix. Because we want it to be center of the crankshaft. That's why the bar is going to be Y0. And then X is going to be wherever the blue, I don't remember. I'd have to look at I got a blueprint. I'd have to look at the print. But especially when you're worried about valve alignment and all of that's why I like to go off the dial pin. So like in the milling machine, we can sweep or probe that dial pin hole and then reference everything from that dial pin. And then when we work on the heads, we can reference everything on the cylinder head from the dial pin. And we know that the bore spacing is 4.4. So You know, it's just a little bit of math. So once you find the dial pin, and then you know where this hole is, then we never move in Y because we've already established the mains are Y0. So it's just, you know, the dimension from the dial pin to here, and then from here to here is 4.4, and then 4.4 more, and 4.4 more. And if you do that, all of the bore spacing is going to be accurate. But I've checked some blocks, some factory, especially this later model stuff, and the position and accuracy of the cylinder bore is within a couple of thousandths. And you know, when I say a couple of thousandths, that's a really big number. But in real life, I mean, a sheet of paper is 3 or 4 thousandths. So it just doesn't matter. I mean, 3 or 4 thousandths when you're talking about bore position, and it's just irrelevant. Now, if we're going to do it, we want to do it to the best of our abilities, like everything else. But just the thermal expansion and cycling is moving stuff around more than that. So I think some people get, you know, in their mind, they think that it's got to be this certain way, or it's not any good, or, you know, they just hear things on the internet and they don't really grasp what's happening sometimes, why it may or may not matter, or why a thousandths or two is no big deal. And so I'm just trying to make that make sense, because a lot of people mentioned it. But my manual boring bar will position on a hole within a thousandths, 2 thousandths. So wherever it was, we're going to be within a thousandths pretty much, you know. And so that's more, and you can look at the gap between the cylinders and see that it's pretty doggone accurate. Having said that, I did find a Y-axis servo motor for the VF3 machining center. So I hope in the next month or so we get a minute. We're gonna get all that back together, and we'll be doing all this nonsense back in the CNC instead of having to do it manual and take 3 days. All right, so that's the positioning lesson for today. We got this side done. We brought it to size with 400 grit. I'm gonna just dust through it with 500 grit just to try to make it as slick as we can, and that will pretty much finish this side. We got to do the same thing to this side, and I'll let you see a little bit of honing on this side. And then once all of that's done, it'll get a thorough washing, and then we'll be ready to put the sleeves in. And generally what I do is I've just got, you know, one of them big old burner heads like you kill your weeds in your driveway with, and we'll just heat up a cylinder, drop a sleeve in, heat up the next cylinder, drop a sleeve in, on and on and on. And then we always just set a head on and tighten it down. That way as the block cools, it don't try to push the sleeve up. So we'll get started on this next side and let you see some of that. And then maybe, I don't know when, but maybe sometime real soon we'll get to see some sleeves go in some holes. And I mean, once all this is done, we'll have a little bit of deburring at the top to deal with, and again, we'll have to wash it really good, and some file work and stuff. Make sure there ain't no burrs or any of that kind of nonsense. We got to get the bottom of our hole set. And you can hear that hole ain't round. I mean, I can hear it. And like I say, that's just from all that material you taking out of the hole beside it, and it just makes it go out of round. But I left about, I think 3 or 4 to home. So, I mean, there's plenty of material to get it round. Now, back in the day when we used to do some Briggs and Strattons, a lot of them were aluminum cylinders. They didn't even have a liner. And man, we bored them things and put a piston in them and send them on. It's amazing to me that, you know, iron rings will run on an aluminum cylinder, but they did it and did it for a long time. Yeah, so that's just a couple of tenths. So we pretty much are. And see, it really don't, I mean, you see how long that took. It really don't take that long. And I mean, I know there's some washing and a little bit of deburring, but it really don't take that long to go that extra step to just, you know, make it. And I ain't saying you can't put a sleeve in a bored hole, but man, putting it in a honed hole is just, you know, it's such a better job. We're getting close, about 1.5 or so to go. About 2 tenths. All right, I'm gonna finish these next two, and then I'll bring you back and we'll get this little centers knocked out and deburred, and I'll show you that. All right, so we got all of them honed, and then I went back with 500 grit and I dusted 500 grit through all of them. So they're all on size, they're round, they're straight, and I'm gonna show you like this little, I just break that little, because it's so thin, it'll mess around when it gets hot and it'll get in the way of the sleeve. So I just knock it out of there, and then I'll just take a little file and just kind of smooth it up and make it flat. So it, because you know, when you put heat on it, it'll melt that little edge over, and you don't want that getting under the sleeve and holding the sleeve up. And it will if you ain't careful. So anyway, you get the idea, and then obviously there's not a burr, but there's no chamfer here. So we'll come in here with a little rotary burr or maybe even a cross buff or something, and just break that edge so it's smooth. And then once all that's done, then pretty much it's ready to take the sleeves then. So I'll finish deburring all this stuff, and we'll get it washed. And then once it's washed, I think we'll just call this an episode, I think. And then once we get it washed and get everything deburred and ready, we'll just hang it on a stand, and then we'll make putting all the sleeves in it another episode. I think that'll be the easiest thing to do. So just be on the lookout. I hope maybe we can get to, this is Friday. I hope maybe Monday or so we'll be ready to put the sleeves in it. So we'll bring you back when we do that. But this will be episode 2. Thank you again for watching, and I hope all that made sense and it was educational. I'll see you on the next one.